Hello, my name is Ryan Cattell and I'm a meteorologist here at the National Weather Service in Los Angeles, Oxnard. The purpose of this video is to provide our marine users with a digestible resource concerning some major changes coming for the way that we forecast and describe the ocean waves in our products and services. So without much suspense, here are the changes. Looking at these examples on the left-hand side, on the top, you'll see an example of our current format with the wave information highlighted in yellow. On the bottom, you'll see the new format coming very soon, also with the wave information highlighted in yellow. A few things to point out. First off, you'll notice in the new format that the swell and wind wave terms have been removed and replaced. You'll also notice in the new format that there's a new wave detail section that includes all the wave systems in terms of direction, wave height, and period. You'll also notice the inclusion of a seas parameter, which is a combined total seas for each period. These changes are going to affect our coastal waters forecasts, which is the flagship marine forecast available on our weather.gov websites, as well as the weather forecasts available on most marine communication radios through the weather button available there. So these changes will affect those services. These changes are expected to come towards the end of this month, May 2024. And before we go into more details about these changes, let's define and emphasize a few key terms going forward. We describe waves in some basic parameters. First off, by height. This is the height or the distance from the bottom or trough of a wave to the top or crest of the wave. You can see the graphic on the left-hand side for reference. We also describe the waves by wavelength. This is the distance between two successive waves, best visualized by the distance between two wave crests. Another way to describe the wavelength or wave spacing is in terms of period. This is the time for two waves to pass a fixed point, best visualized again for the time for one wave crest to pass and then the next. Now, to emphasize the importance of looking at all these wave parameters, consider these examples. All three of these waves show a wave height of 10 feet, equally sized waves. But without any more information, you wouldn't be able to tell if just given the information of a 10-foot wave, whether the waves are like the left-hand side or the right-hand side. But with the period information, you can better assess the sea state. On the left-hand side, you'll see a 10-foot wave with a 20-second period. That's considered a very long period. The waves are very far apart and well spaced. And most of the time, the sea state is relatively calm and flat, despite the relatively large 10-foot wave. Right-hand side, same 10-foot wave, but with a much shorter period of 6 seconds. These waves are much steeper, closer together, and more frequent. This is a very hazardous situation. Let's go back to the coming changes and look at a few more examples. Here are 4 examples of the current format and the new format for the same situations. So the top 2 boxes show the same wave situation, but in the current format and the new format. I encourage you to pause the video at this point and take a look at each of these examples to see that they're both describing the same situation and really understand the changes in the descriptions and the terms. Hopefully you had a chance to pause and look over these examples. And you'll notice that the terms that we have all grown to be accustomed to and have used for a long time, namely swell and period, will be replaced with descriptors of the waves by those basic wave parameters that we just described: height, period, and also direction. This is the same information presented just in a different format with a different syntax. To see that, let's look at one specific example. Consider this example. Look in the blue box on the left of a situation where there are wind waves of 2 to 3 feet and a south swell of 4 to 6 feet at 18 seconds. Let's focus on the wind wave first. Wind waves, that term, is hopefully communicating the idea that these waves are a short period, usually steep, and often accompanied with whitecaps. A typical example of a wind wave would be something like a 3-foot wave at 6 seconds. Looking numerically, you can key in that this is a steep wave and likely a wind wave by seeing that the numeric value of the wave height is very similar to the numeric value of the wave period, 3 versus 6. Contrast that with the swell. In our example, south swell 4 to 6 feet at 18 seconds. The swell term is somewhat unneeded because we already described the wave height and period, but it is communicating that this is most likely a very well-spaced wave, less steep wave, a more gradual wave. That is a swell. Usually a longer period wave, and again, gradual, less steep. A good example of a swell is something like a wave of 6 feet at 18 seconds. Numerically, you can key in that this is a swell by seeing that the numerical value of the wave height, 6, is much less than the numerical value, 18, of the period. Why are we removing these terms? There are 3 reasons that these terms are being removed. First off, waves do not always fit neatly into either a wind wave or swell category. Sometimes waves are more like a wind wave, although the winds are calm because the winds are strong nearby. Sometimes waves aren't really a wind wave or a swell, and something in between. Secondly, another reason is that these terms can really mean different things to different people. Some people might think of a wind wave as more of a short period swell, and some people might think of a short period swell as a wind wave. As well, some new boaters are not familiar with these terms at all, and some boaters visiting from other parts of the country or the world are not familiar with these terms as well. And so understanding these terms is key in the current format, and it's not always safe to assume that people understand what these terms mean. And lastly, number 3, these terms are not being used in every region in the United States, and really mainly only used in the Pacific Ocean region. One of the big motivators for these changes is to come up with a nationally consistent wave format so that no matter where any mariner visits throughout the country, they can expect the same wave detail information in the same format. These changes will provide a nationally consistent format and message in terms of the waves. And for those 3 reasons, it was decided to exchange these swell and wind wave terms with the raw wave parameters. With all that said, the wind wave and swell terms have been powerful descriptors for decades. Their absence will certainly take some getting used to, and we absolutely recognize that this will be a difficult change for some. With that in mind, we have created a lot of resources to help with this transition. Access to these resources will be presented at the very end of this presentation. A few other things to consider and understand with these changes. First off, as mentioned before, the total seas and significant wave height will be included in every period with that seas terminology. This is an addition to the current format. Second, wave direction period will also be included, at least for the first 3 days of the forecast, if not all 5 days, which is locally dependent on your local area. Third, the detailed height will be simplified to just the upper end of the range. So instead of seeing a wave detail section, something like a west 2 to 4 foot wave, you'll just see a west 4 foot wave, condensing it down to a single value, highlighting the upper end of the range. This is to shorten the product and also help the mariner not have so many numbers to try to understand. Fourth, the individual wave groups in the wave detail section will be sorted by period. The shorter period waves will be mentioned first, and the longer period waves will be mentioned last. This is very similar to the current format, with the wind waves being mentioned first, which are usually of shorter period, and the swells being mentioned last, which are of longer period. This will hopefully help in the transition period. Fifth, if waves are considered insignificant, meaning they're small on their own right, of 1, maybe even 2 feet, or they're small compared to other wave groups or wave systems, such that, for example, if there was a 10-foot wave as well as a 2-foot wave, the 2-foot wave will be ignored and not mentioned because it is small and insignificant compared to the larger wave systems around. And lastly, if you are a user of our point forecast service, these changes will not be included in that forecast, and those changes are expected to come later next year. We will still provide forecast information, but it will still include the old format of the wind, wave, and swell information. Now, while many people do not like tests, they can help us further understand changes and new information. So I have 4 quiz questions that we can just kind of participate in together that will hopefully help us further understand the principles just presented. So the first one, look at these 3 examples, these 3 animations, and match the wave descriptions by their key parameters with each animation. Go ahead and pause the video if you need some time. Okay, so hopefully you had enough time. Here is the answer. Second question, order these waves from largest to smallest in terms of height. Go ahead and pause the video if you need more time. Okay, so here is the answer. The largest wave is actually animation A, although it looks rather flat because the period is so long, the actual wave height is higher. The smallest, animation B, actually looks the choppiest, the steepest, because the period is the shortest, even though the wave height is the smaller. So really the purpose of this quiz question is to highlight that height alone does not really describe what you can expect out there on the waters. You need the wave height and period together. Number 3, let's look at the wind, wave, and swell term examples. And ask yourself, which one of these is most likely a wind wave? You can look at either the animation. I would encourage you to look at the animation and the actual raw wave parameters and determine which one is most likely a wind wave. Go ahead and pause the video if you need more time. Okay, let's look at the answer. The most likely wind wave of these 3 is number 2, or letter B in the animation. West 4 feet at 5 seconds. Numerically, you can look at that and key in that the wave height value 4 is very close to the period value of 5, which shows that these waves are very close together, rather steep, and most likely a wind wave. Here's our last question. Just looking at the wave descriptions by the key parameters, which one of these is most likely a swell? Go ahead and pause the video if you need more time. Okay, let's look at the answer. There are actually 2 possible answers. The most likely one that is not a swell and most likely a wind wave is option number 1, which matches up with animation A. You can see that the numeric value, 3 feet, is very close to the numeric value of the period, 4 seconds, and most likely a very steep, if not a wind wave. The other 2 could be swells. If you look at number 2, that's the most likely candidate for a swell. The numeric value of the wave height, 6, is much less than the numeric value of the period, 14 seconds, which tells you that these waves are very far apart and very gradual, most likely swell. Number 3, which matches with animation C, is likely a swell as well, but a little bit steeper than option number 2. Still, the numeric value of 5 feet for the height is much less than the numeric value of the period, 10 seconds, so this is most likely a swell, but it is getting closer to a steeper wave. As mentioned before, there are resources available to you. First off, I encourage everyone to check out the webpage that has been developed dedicated to this project at weather.gov/marine/wave detail, also available through the QR code to the right. If you still have more questions or concerns, please reach out to us through our webmaster account, which is emailed there, and we'd be more than happy to help you and even set up a phone call if you need more information. We thank you in advance for your patience during this process. It will be an adjustment process. There will be a transition phase, not just for our mariners, but also for our forecasters. This is a change for everyone, and we look forward to making this change together and better serving you in the future. Thank you for your time, and please reach out if you have any questions.